Okay, so like I said, the surface area problem is just a little bit tougher. I think it's easy if you, honestly, if you pick up a cereal box at home and realize that is a rectangular prism. And if you kind of look around, there's three distinct different sides to something like a cereal box. Okay? We often like to think of a rectangular prism as having a square base, but that's not necessarily the case, right? They would have told us that if that was the case. So we've got these two faces right here. Now let's change the color here. I'm getting used to this new toy of mine. Let's see. Okay, we got red. So then we've got these two faces down here. Okay, now where is that other one? That's the top right here. And our last set of faces is actually this face. I'm going to have to go through, but it's this back face right here. Okay, kind of difficult to see, but really, you just need to remember there is always a height, a width, and a length. I need to get a better stylus. And we're going to have 2 of the height times the width, plus 2 width times length, plus another 2. Let's see, which one do we not get? Height times length. Okay, so each of these separate binomials are going to stand for the height, the width, and the length. Doesn't matter which ones we assign, just got to make sure that we get all the different combinations. So let's go to the next slide and attack this problem. Okay, so we've got 2 times x plus 3 times 2x minus 3. And let's just do that one out. Obviously, we've got 2 other combinations to do, but we've got, we're going to have 2x squared minus 3x plus 6x minus 9. Let's simplify. So we've got 2x squared plus 3x minus 9. And the total of those two faces are going to be 4x squared plus 6x minus 18. Okay, so that is one of 3 parts of this problem. This is going to be 2 of the faces. We need to go get a product that represents the other 2 faces, and then another product that represents the other 2 faces. So that's the first one. And just make sure you keep track of which ones you're doing. So x plus 3 and 2x minus 3 was this one. So now I'm going to do 2 times x plus 3 times x plus 1. And that's going to give us x squared plus 3x plus 1x plus 3. 2 times x squared plus 4x plus 3. And the total surface area that's dedicated from these 2 plates, or faces, sorry, not plates, 2x squared plus 8x plus 6. Okay? And obviously, if you're doing this on a single piece of paper, it's much easier, but I'm limited to space. Okay? So now we've got a polynomial that represents the surface area of 2 more faces. And now for the last one, we've got 2 of the x plus 1, it's a plus, times the 2x minus 3. 2 times 2x squared minus 3x plus 2x minus 3. Okay, simplify. Going to get 2 times 2x squared minus x minus 3 for a grand total of 4x squared minus 2x minus 6. Okay, so we've built our three groups of faces, and now on the last slide I'm going to add them all together. No particular way that's, desired here. Just for sake of space, I'm going to actually add these up and down. Plus 6x minus 18, 2x squared plus 8x plus 6, and 4x squared minus 2x minus 6. So if we add all these up, these guys are going to go away. So we're just left with negative 18. And then we've got 6x plus 8x. So we're at 14, and then minus 2. That's going to get us to a positive 12x. And then we've got 4x squared plus 2x squared plus 4x squared, making a grand total of 10x squared. Okay? So that is a polynomial expression that represents the surface area of that rectangular prism. And of course, we know we could factor that. Let's see, we take a 2 out, we're left with 5x squared plus 6x minus 9. I wouldn't go any further than that. I mean, maybe if you were actually given a value for what this surface area was, and then you had to find x, then that factoring would be helpful. But in terms of just looking for an expression, that is good, or that would have simply been good. All right, let's go to the next problem.